Next, let us see the question. Find Laplace transform of t into cos 3t. So here we are going to use the property called multiplication of t property, that is L of t into f of t. What is L of t into f of t is minus d by ds of f of s. F of s is nothing but L of f of t. So we can also write like this. So now we can apply this property over here. So L of t cos 3t is equal to minus d by ds of L of, in place of f of t, we are having cos 3t. So this is equal to minus d by ds of, formula for L of cos 3t is s divided by s square plus 3 square is nothing but 9. So now we have to differentiate it. So this is equal to, minus is common here. So now we are differentiating it. So we have to use u by v rule. So that s square plus 9 whole square in the denominator. In the numerator here, s square plus 9 into differentiation of u is 1 minus s into 2s. So this is equal to minus of, numerator if we simplify, this is s square plus 9 minus 2s square divided by s square plus 9 the whole square. So here this we can write it as s square minus 2s square is minus s square. Already one minus is outside, so that we can make it as s square minus 9 divided by s square plus 9 the whole square. So this is the answer for L of t into cos 3t. Next is find L of e power minus 4t into t into sin t. So here we have to use both the property, first shifting property for e power minus 4t and the multiplication of t property for this t. So here this is equal to, first let us apply first shifting property so that we can write L of t into sin 2t, where s should be replaced as s plus 4. This is what first shifting property. Next, again for this term, multiplication of t property is minus d by ds of L of sin 2t, where whole thing s should be replaced as s plus 4. So now we know that L of sin 2t is nothing but 2 divided by s square plus 4, which after differentiating this, finally we have to substitute s by s plus 4. So here first let us differentiate it. So here minus is common. Differentiating it, denominator becomes s plus 4 whole square, and then here in the numerator is, if you differentiate numerator, it becomes 0 minus, again here 2 into 2s. Close the bracket, s is replaced as s plus 4, right? Actually here you have to remember the formula u by v dash. So u by v dash is what? V square, and then here v into u dash minus u into v dash. So here the numerator is yes, here 2. So differentiation of constant term is 0. So minus again 2 into differentiation of the denominator is 2s here, divided by s square plus 4 the whole square. Finally this s should be replaced as s plus 4. So finally here, if you see the numerator, 2 minus 2 into 2s is minus 4s. Already one minus is here. So we can write it as 4s divided by s square plus 4 the whole square, where s is replaced by s plus 4. So this is equal to 4 into s should be replaced as s plus 4 divided by here again s plus 4 the whole square plus 4 whole square. So either we can stop up to this, or if we want to simplify further also we can simplify. So this is the answer for what? L of e power minus 4t into t into sine 2t. Now let us see the question. Find Laplace transform of 1 minus cos t divided by t. So here we are going to use the property, division of t property, that is L of f of t divided by t is nothing but integral s to infinity f of u du, or otherwise this f of u can be written as usual notation, that is L of f of t into du. Right? So this is the property we are going to use here. So now L of 1 minus cos t divided by t can be written as integral s to infinity L of 1 minus cos t into du. Now we have to find this L of 1 minus cos t separately. So here let us find what is L of 1 minus cos t. So this is equal to, this is very simple. First we have to split it using linearity property. So this becomes 1 by s minus again this becomes s by s square plus 1. So now keep it in mind, L of 1 minus cos t can be replaced as 1 by s minus s by s square plus 1. So now we have to substitute here, so that L of 1 minus cos t divided by t is equal to integral s to infinity. Here while writing it we have to replace it in terms of u because the limit is already in terms of s. So that here we can make it as 1 by u into, minus u divided by u square plus 1 into du. So this is equal to, now we can integrate it. So integration of this will give you log u, the first term, minus this is 1 by 2 into log of u square plus 1. Okay. So this, if you want to do it, here you can put u square plus 1 is equal to some t. So that 2u du can be replaced as dt. And integration of u du by u square plus 1 can be written as integral u du is nothing but dt by 2 divided by t. So taking 1 by 2 common, integral this becomes dt by t, which is equal to 1 by 2 into log t. So finally log t can be replaced as u square plus 1. So this is equal to 1 by 2 into log of u square plus 1. So this is what directly here I have written it as minus 1 by 2 into log of u square plus 1. So this is the integration where the limits are s to infinity. So since the limit is infinity, we can't able to directly substitute as here log infinity. It is undefined. So that how to write this term is, we can write it as, it is of the form log a minus log b, which we can write it as log a divided by log b. So that here what we can do here is u divided by, since we are having 1 by 2 here, we can write it as square root of u square plus 1. Now substitute the limit s to infinity. So this, before substituting the limit here, denominator you can take u common so that it becomes u into root of 1 plus 1 by u square. That is, we are taking u square outside the square root. So if you take u square outside the square root, it becomes u here, and then here it becomes 1 plus 1 by u square. Now you apply the limit s to infinity. So this u and this u get cancelled. So once u tends to infinity, 1 by u tends to 0. So that here for the upper limit, it becomes 1 here because 1 by u square becomes 0. So 1 by 1 is 1. So log 1 is the upper limit minus lower limit is simply we have to substitute u is equal to s. So that it becomes like this. 1 plus 1 by s square. That's it. So this is upper limit and this is lower limit. So here one more thing you have to remember, log 1 takes the value 0. So that here this first term will become 0. So that minus log this, if you simplify this, we can write it as s divided by root of s square plus 1. Simplifying this, you can write it like this. And moreover, we are having minus here. Since we are having minus, we can write it as log of root of s square plus 1 divided by s. That is, we can write it as a reciprocal of this. So final answer is log of root of s square plus 1 by s is the final answer to the question L of 1 minus cos t divided by t. Next question is find L of sin t by t. So L of sin t by t can be written as integral s to infinity L of sin t into du. So this is equal to integral s to infinity L of sin t is what? 1 divided by u square plus 1 into d. So now integration will give you tan inverse of u over the limit s to infinity. So this is equal to, now applying the limit, tan inverse of infinity minus tan inverse of s. But we know that tan inverse of infinity is nothing but pi by 2 because tan pi by 2 is infinity. Minus this, we can write it as tan inverse of s. So this is the answer. If you want to leave, we can leave as it is, or this can also be written as cot inverse of s. So L of sin t by t is equal to cot inverse of s.